So we are going to continue on with chemical reactions, taking a look now at single displacement reactions. So a single displacement reaction is when one element displaces or replaces an ion in a compound. So like we saw earlier, it would be when you have AB plus C reacts to make AC plus B. And as we can see here, we have our C that is coming in and replacing the A. That is our single displacement there. So we also have something called the activity series. So if you take a look here, this is your activity series of metals. So this we are going to be using for single displacement reactions, RXN for reactions. So what that activity series is, and I would recommend having it beside you somewhere while I'm teaching you this lesson. So it's a table of the reactivity of metals relative to each other. So how much more reactive is one metal compared to the other. So the most reactive metals are at the top of that activity series, and the least reactive are then found at the bottom. Hydrogen, although it is not a metal, is also included in the series, even though it is not a metal, because it can form a positively charged ion, right? You can have H+, and remember that metals are cations, and so hydrogen can act as a metal if it carries a positive charge, remembering it could lose its one valence electron, or hydrogen would have a negative charge if it gained an electron, and there it would have non-metal behavior. That's just a review from our last unit. So the activity series is based upon two important generalizations. So one element can displace elements below it from compounds in solution, but cannot displace elements above it. And the farther apart the two elements are, the more likely it is that the displacement will occur. It could be quickly or spontaneously. So I'm just going to talk about that for a second while looking at my activity series. So what this means is, so in a single displacement reaction, remember you have A plus or AB plus C, right? And I know that this C is going to come in. Well, now we're going to have to determine whether or not the reaction will occur. So the reaction can only work, it will only work if C is stronger, I like to call it, i.e. more reactive, than A. So for example, if C was iron, and if our A was hydrogen, the reaction would occur because our C would be higher than our A. Conversely, if I had lead as my C value and magnesium as my A value, no reaction would occur because my C is not more reactive than my A. And we'll go through some practice of that in a minute. So like I just explained, to determine whether or not a reaction between an element and a compound will react, look at the relative reactivities of the two metals. If the higher, so more reactive, I always like to think of it as stronger, metal, is the free element, So notice how here it just has opposite, but this one is by itself. So that one has to be stronger than B in this example for it to occur. So the reaction will proceed. If the higher metal is in the compound, so if B was stronger, then no reaction occurs. So when you have A plus BC, you're going to end up with AC plus B. So there are three different types of single displacement reactions that we're going to take a look at, and these ones all involve metals. So you could have a metal and an ionic compound. Remember that an ionic compound is just a metal and a nonmetal. Your nonmetal could be a polyatomic ion, right? So I have magnesium plus copper sulfate, right? I know that this sulfate ion is my nonmetal ion, and that's copper. So all I'm comparing right now is the strength of magnesium compared to copper. So I'm going to take a look at magnesium and copper on my activity series. So my magnesium is right here, and my copper is right here. So my magnesium is stronger than my copper. My magnesium is my free element, so my magnesium will want to bond more strongly. So my magnesium is stronger than the copper, so the magnesium is going to kick the copper out of its place, which is going to allow the magnesium to then be bonded with the sulfate. Remember that magnesium has a 2+ charge, sulfate has a 2- charge. When I cross those charges, I just end up with the MgSO4 plus, now I'm going to have just regular old copper metal. This would be aqueous because it would be dissolved, and copper metal. Now if I take a look at the next example here, we're going to compare lead and zinc. So the reaction is only going to occur if our lead is stronger than zinc. So if I look at the reactivity series, and I go and I find lead, and I go and I find zinc, my lead is not stronger than my zinc. My lead is not more reactive than zinc. So what ends up happening here is this reaction will actually not happen. So you're going to write no, RXN. RXN is this short form for reaction. So the reaction between the magnesium and the copper sulfate occurs because magnesium is more reactive than my copper, but the reaction between lead and zinc nitrate does not occur because lead is less reactive than zinc. So whatever element is free, so on its own, has to be stronger for the reaction to occur. It has to be more reactive. So we have another type of reaction. Our second type is reactions that involve a metal and an acid. Okay, remember when I have the acid, this is going to carry my plus charge, and this is going to be my acting as my metal. So now when I take a look at the activity series, I'll use a different color because I've already used blue. Let's do green. I'm going to compare lithium with hydrogen. So when I go and take a look, lithium's way at the top, very reactive, and my hydrogen is down here. So my lithium is stronger, is more reactive than my hydrogen, therefore the reaction will occur. So once I know that the reaction will occur, I'm going to put those together. So now I know that the lithium's going to come in and replace this, and my hydrogen is going to be on its own. So hydrogen, remember, is a diatomic molecule, a Hoover-Finkel molecule, so I have to put the 2 there. It is H2, which is hydrogen gas, plus now I have lithium, which has a 1+ charge, and I have my sulfate, which has a 2 minus charge. So when I do my crisscross, I will end up with Li2SO4 from my crisscross of my charges here. So I will end up with hydrogen gas and lithium sulfate. So the reaction between lithium and sulfuric acid occurs because lithium is more reactive than hydrogen. And that's pretty much all we have to do. The last type we could have is our reactions between a metal and water. So in water, we have our hydrogen. One of these hydrogens is going to act as an H+. The other one is going to form a hydroxide ion, our OH-. I still have H2O, but what I'm testing right now is still whether or not hydrogen will be stronger or weaker than my free element to determine if the reaction will occur. So now I'm going to take a look for sodium and hydrogen on my activity series. So let's look. Sodium is up here. Hydrogen, again, right down here. So my sodium is more reactive than my hydrogen, so it will displace it in this reaction, and the reaction will occur. So that's always my first check. So this is going to come in and boot that out. So now I'm going to have Na, and it's going to now bond to this OH hydroxide ion. This has a plus and a minus charge, so if I cross the charges, I will just get NaOH, and I will have hydrogen gas. Right, because think of it as displacing this H2. Obviously, this is not balanced. The next step would be to balance these equations, but the reaction occurs because sodium is more reactive than hydrogen. Also, a good thing to note is your group 1 alkali metals are very reactive with water. And you remember that from the videos that I showed you in class of the different types of reactions with water from all the group 1 elements. So there's a second type of single displacement reactions because it can also involve halogens, right? Your halogens are your group 7 elements. And those are very reactive as well. So elements of the halogen family have their own activity series. So here's how it goes. The most reactive is fluorine, then chlorine, then bromine, and then iodine. Okay, just these 4 for the nonmetals. So a single displacement for our nonmetals would pretty much just look like where A would be a nonmetal and it would be displacing this nonmetal. So you would end up with C plus AB. So the single displacement pattern for halogens is slightly different from the pattern used for metals. This is because a negative ion, remember nonmetals are negative ion, which is called an anion, is being displaced rather than a positive ion. So now all we're looking at here, and the only clue I need to know is whether my free element is a metal or a nonmetal. If it's a nonmetal, I know I'm looking at my nonmetal, my halogen activity series. If it's a metal, I use the regular one. So all I'm seeing is, will chlorine displace iodine? Okay, so let's take a look. Is chlorine stronger or more reactive than my iodine? It is, because I can see chlorine is above the iodine. So the chlorine is going to boot out the iodine, and the iodine is going to end up by itself. Remember that I need to put I2 because it is a Haber-Finkel, which is a diatomic molecule, and it is a gas. Now I'm going to have potassium mixed with chlorine. It's just going to end up giving me KCl, because when the cross is charged, that's what I'll be left with. So after this reaction occurs, I will be left with these two elements. So this reaction occurs because chlorine is more reactive than iodine. Okay, now we'll check out the other one here. I have iodine and bromine. Well, iodine is less reactive than bromine. So will this reaction occur? No, it will not. So now I write no reaction. This reaction does not occur because bromine is less reactive than iodine. Okay, and that's pretty much all for today. I'm just going to give you some tips of stuff to put into our simplified notes. So I'd like you to take a look at this, and we're just going to fill this out here. I'm actually going to move this up a little bit, give myself a bit more room. Perfect. So altogether, we could technically have 4 different types of these reactions, and so always remember, this is an important thing. So here is where we use the activity series, and you will always be given the activity series for a test or exam. Another important thing to remember is that it always only occurs if I'm going to call it a single element, is more reactive than the element in the compound. Okay, little note there. So sometimes, otherwise you will end up with no reaction, and that's okay. So the first example that we took a look at, right, was if you had a metal and an ionic compound. There you just end up with a new compound and a metal. So for example, I'll use the example if I had zinc plus copper sulfate. The zinc is stronger than the copper, so I will just end up with copper and zinc sulfate on its own. Remember that the second example was when we had a metal and an acid. Right, that's going to make a salt and hydrogen gas. Right, because an acid always has hydrogen in it. So for example, if I had magnesium plus HCl, right, I know magnesium is stronger. I will just end up with hydrogen gas and magnesium chloride. Third example, right, when I had a metal and water. Actually, instead of water, I'll write H2O. We should all know H2O is water. Here, we always end up with a base and hydrogen gas. For example, let's say my metal is sodium plus water. I will end up with NaOH plus hydrogen gas. Lastly, is if we have a halogen and a halide, right? This is taking a look at the nonmetals, a halide compound. We will end up with a new halogen and a new halide compound. For example, I know that chlorine, I know that chlorine is stronger than iodine, so it's going to boot out the iodine, so I am going to have iodine by itself, and now I'm going to have KCl, potassium chloride. This is a gas too. And for this one, you just have to remember to use the halogen activity series. So this one can take a little bit to get used to. What I am going to recommend is that you do the practice questions from the practice page that I gave you on this. Go through and do the practice problems. The more you practice this, the better you will be. And remember to use the activity series. And good luck this weekend, and I'll see you all on Monday.